Good morning. It is Friday, March 7th, 2025. This is Landon Blake, ruggedly handsome land surveyor extraordinaire. This is yet another truck brain dump. This is my second truck brain dump for Friday morning. I feel pretty productive considering it's a Friday, end of a long week. I think this might be my fourth or fifth brain dump for the week. So I had a good week. It was a good week for truck brain dumps. All right. What are we going to talk about in this one? I'm going to talk a little bit about why we use Python as our programming language of choice at Redefine Horizons. We are starting to more actively develop software now that deep learning tools have made that an order of magnitude more productive. So I am personally writing more code now, and some of the team is starting to write code. James is writing some code, and Brian has been tinkering with some code for some point cloud stuff, which is just cool. James has written some Python scripts for QGIS, so we're geeking out. What I want to do is tell you a little bit about Python and why we chose it as a programming language. We'll talk a little bit about the difference between an interpreted language and a compiled language, and we'll talk a little bit about the difference between dynamic typing and static typing. And then we'll talk about some of the advantages that Python has as a programming language and why we've decided to use it as our primary programming language at RH. And then we could talk about some other languages that we might write code in. And then I'll wrap up by telling you about some of the Python programming projects that I'm currently working on. So let's start by telling you a little bit about Python, and we'll talk about the difference between a interpreter and a compiler, and between a statically typed language and a dynamically typed language. Python is an open source programming language. As far as I know, it's actually not named after the snake. It's named after Monty Python, who Monty Python is the name of a movie. Python is an open source language created primarily by one person, Guido. It's got a much larger community now. He created Python, and I think he's still the benevolent dictator. Python is now maintained by Foundation. So it's open source, which I like. It means you don't have to pay for it. Just downloads to your computer. And all this, what they call the standard libraries, are available for free. Python has a number of kind of snarky mottos. One of them is Python is batteries included. That means a lot of the functionality you need is included in the standard libraries that come with the interpreter, with the Python development environment, which is helpful. It speeds up development. There's a large collection of what they call third-party libraries, or Python, they're called packages. So they have the PyPy, PyPI, the Python package index. It's a collection of open source third-party libraries for Python. So Python is what we call an interpreted language. So what that means is that when you execute a Python program, the code that makes your program do stuff is the source code executed at runtime by another program called an interpreter. That's why Python is called an interpreted language. The Python interpreter is a Python program called python.exe, written in the C programming language, which is a compiled language that's a little lower level. All of your Python source code gets interpreted at runtime, like live television, in the Python interpreter. Python interpreter does stuff. It shows you a window. It opens a file. It prints a message to a dialog box. It shows a dialog box with a message when you click a button. So a Python program is really just a set of instructions, which we call source code, that's being given to the Python interpreter. It's essentially a list of commands for the Python interpreter. So how is that different from a compiled language? And then you could talk for an hour about it. I'm going to try and keep this brief. So in a compiled language, you're still giving instructions to the computer, but in a compiled language, those instructions are converted or compiled by a tool called a compiler into machine code that runs on your central processing unit. So, for example, if you write a program in C++, that gets compiled by a compiler, that source code becomes an exe that runs directly on your CPU. So there is no program in between your source code and the CPU. In an interpreted language like Python, Python is a C program running in between your Python source code and the CPU. It gets a little bit complicated because that is not a black and white line. So there are hybrids, and Python itself is a little bit of a hybrid. So when you run most modern Python interpreters, they will make a kind of compiled version of your code called bytecode that executes faster than raw Python source code, but not quite as fast as machine code. So it's a hybrid. Most modern Python interpreters are somewhere in between. So they're not purely interpreted, but they're not compiled. They're in between. And that is the technique taken by most modern programming languages now. Java is also a hybrid. A lot of people will tell you, well, Java's compiled. No, not really. It is compiled, but you compile Java to bytecode that runs in a Java virtual machine, not to machine code. And same thing with C# and other .NET languages. Those compile to bytecode that runs in the .NET virtual machine. So most languages follow the hybrid pattern, but it's not a black or white line. It's not an either or, it's a continuum. Python is more towards the interpreted side and less towards the compiled side. That Python is what they call dynamically typed. What that means is, in essence, when you write your Python code, you do not have to tell the Python interpreter what type of data your source code is working with at a low level. So you don't have to tell Python, this is a floating point number, this is an integer or whole point number, this is a string of characters, this is a collection of bytes, this is a date, this is a Boolean. You have to do that in a statically typed language like Java, C# or C. You do not have to do that in Python. Python will look at your data and the way you're using it and figure that out on its own. That is called inference. It will infer the data type from its appearance and the way it's being used. That is a super powerful feature of dynamically typed languages. What it means is you don't have to type as much. Now, there's some trade-offs. A dynamically typed language is more flexible. In Python, they have another kind of snarky saying. They say Python is duck typed. What does that mean? Duck, D-U-C-K, like the bird, duck typed. That means if it walks like a duck and it quacks like a duck, it's a duck. So that means they look at the data that you're using in your program and they say, if it looks like a number and it acts like a number, we're going to treat it like a number. If it looks like a string of characters and it acts like a string of characters, we're going to treat it like a string of characters. So that makes Python more flexible. It's more dynamic and able to bend a little better. For example, you could write a Python function that takes any type of data and prints out a message to a dialog box. You could give it a number or you could give it a string of characters and it would show that message in a dialog box. You can't do that kind of thing in Java. or C sharp. In Java or C sharp, you got to write different functions. You got to write a function to print a number, and then you got to write a function to print a string. You can't have them be the same function. But Python has that flexibility because it's duck typed and it knows that it can print a number like a string. So there's some advantages to duck typing. Makes the language less verbose. You don't have to write as much and easier to learn and more flexible. There is a downside. In a dynamically typed language, you can have more errors at runtime. In other words, when the code is executed. So if you pass a Python method a string and that method is supposed to square a number, it's not going to be able to square a string. And you're going to get an error or an exception at runtime when the program executes. And that kind of error typically doesn't happen in a statically typed language because when you go to compile your code, the compiler is going to tell you, hey, knucklehead, you're trying to give a string to a method that requires a number. And it's not going to let you do that. Compile error. It won't compile your code. So the Python interpreter does not do that. The code is more dynamic. It's more flexible. It's easier to write. It's less verbose. But what that means is you have to do more error checking. You have to have more error checking and validation code in your actual Python program because, you don't have a built-in compiler that's already doing that. There is no compiler with that kind of built-in type check. Now, some very smart people in the Python ecosystem have developed tools to help with that. So there's a tool called MyPy, and they have a new standard called type hints, where you can give the Python interpreter hints about what the data type is, which is a little bit like statically typed languages. You can have a tool like MyPy do some pre-checking of the way you're using type hints and types in your code before it's actually run. So there are some workarounds, but it's not built into the language. I think this is going to be less of an issue now that we have deep learning tools because deep learning tools can analyze your code and automatically add type hints. So you basically get some of the advantages of a statically typed language in a dynamic language like Python without really putting in the extra work because the deep learning tool will basically do a 99.9% effective job of adding your type hints. All right. Why did we choose Python as our primary programming language at RH? Part of the reason is because I like Python. That might be the main reason, but there's some other reasons. It's easy to learn. Python allows for rapid prototyping, which is what we're primarily interested in here. We want to try out ideas for new tools and quickly implement them and test them. We are tech savvy and super geeky, and we have lots of ideas. There's a trade-off between speed of development, execution. It's not as big of a deal as it used to be, but Python code does run a little bit slower than code in a language like C that gets compiled directly to machine code. I will do a separate brain dump about that. But we're way more worried about saving time when we write the code than we are about saving time when we run the code. And that's just because we're experimenting a lot and we're pushing the envelope. And we're much more concerned about our cost of labor as a consulting company than we are about the cost of the amount of time it takes for our software to execute, just because it's typically much, much smaller than the time we spend actually writing code. And we want code that is easy to read and understand and extend and improve. We like that it's dynamically typed. We like that it's interpreted and not compiled. That just makes the program development quicker. We like all the batteries included. We like all the standard libraries that are included in the Python interpreter. We like the great ecosystem or collection of third-party libraries. We have Python libraries that can read DXF files from CAD, shape files, and GeoJSON files. We have Python libraries that help with running statistics and doing linear algebra. There's a Python library for it. So we like that. All that stuff makes Python a fantastic language. I will let you know, I started out actually as a Java programmer, and I've only been writing code in Python for a few years, maybe 2 or 3 years. but I've embraced the language wholeheartedly. I don't think I'll ever write code in Java again. Python is a much better language. Java was very difficult to learn. It was a huge learning curve for me. Python is much easier, so I'm excited. Another reason that we really like Python is it's cross-platform. That isn't hugely critical to us, but it is cool that you can run it on a Linux computer. We do have a high-end Linux workstation. It's a Thelio Astra from System 76, so we do have our first Linux workstation. We like that we can run Python on Linux if we want to, and one of the main reasons we like Python is because Python is the scripting language of choice for QGIS, which is the open source desktop GIS program that we use. We can also use Python in Correlator 3D, which is our soft copy photogrammetry software, and we can use it in some of our point cloud processing software. So a lot of the tools we use, you can script and customize with Python. So that's another reason why we selected it as a language. Let me tell you about a few of the things that I'm working on right now in Python. Spring of 2025, working on a library and desktop application and QGIS plugin to allow for task management and kind of dispatching in QGIS. So I'm excited about that. It's called Force Opus, outside work, Latin for outside work. So it's going to give you the ability to do things like select all the tasks along a particular route or within a particular polygon and put those into a list or create a work order. You could select all the tasks along a route and give somebody a schedule. Just a task management tool for QGIS. I was super excited about it. It's going to have its own desktop app written in tkinter and TTK Bootstrap. And it's also going to have a QGIS plugin. So you'll be able to use it both as a standalone desktop app and as a QGIS plugin. I'm working on another QGIS plugin. It's in the early stages. I'm just doing some prototyping, but it's going to allow you to manage survey points directly in a QGIS database. I'm working on a tool to validate XML using Schematron, RelaxNG, and XSD schema technology. We invented a brand new XML schema language called Verbaclara, and we're excited about that. It does some things that you can't do with the other existing XML schema technology, and that is a desktop application that runs in tkinter. It's Latin for validate or verify. So we're excited about that. That should be released in the next few days. I'm super stoked. It's a super geeky thing, right? It's an XML validator, super geeky, but I'm excited about it. The tools that have that kind of functionality available now are very expensive. And all of our tools are going to be open source. So we're excited about getting that out and seeing what people think about it. What else are we working on? I've got a couple Python programming tools. So I've got a graphical test runner in tkinter. I've got a graphical tool that lets you build single exe files with PyInstaller that we're going to release. We have a library that mocks tkinter widgets for testing, for unit and integration testing that we're going to release. So those three tools are made for other Python programmers. We're working on a triple store database. It's a special type of data space, and we're interested to see how we can apply that to geospatial applications and geography. So we've got a triple store database called Tria Memoria. And then Brian's working on some point cloud stuff. James has been doing some basic QGIS scripting. So we got a lot of stuff cooking in Python, and we're excited about it. We're also working on a 2D geospatial, 2D geospatial geometry library called Figura. It's going to be a pure Python kind of replacement for what they call oh man, I can't remember the name of it. The most popular existing geospatial geometry library actually depends on a C library called Geos, Geos, which means you can have problems installing it and other challenges with that. So we're writing up what they call a pure Python geometry library that's going to have support for circular arcs and complex polygons and polylines. It's the kind of library that you could use to build a simple 2D CAD program if you want. So we're excited about that. We got a lot of stuff. I think RH is going to release a lot of really cool open source libraries, frameworks, and desktop programs this year, 2025. I'm excited about it. We're going to have a little program called RH Labs where we release that software. It's all going to be open source. It's going to be great documentation, both for the end user and the developer, people that are interested in developing that code. And we're going to have some great tutorial videos. So that's a little bit about how we're using Python. We will do some more truck brain dumps about Python as a programming language. We'll talk about performance in Python, and we'll talk about what is this thing about C libraries and how do you manage packages and dependencies. And I'll offer some Python programming tips. We can talk a little bit about how we organize our Python code. And I'll do a brain dump about version control and why you want to use version control. So lots of stuff to learn and teach my people. This is a good start, though. Thanks for listening. I appreciate it.